27 again. So x squared plus xy plus y squared equals 3. And we are given a point, and we are asked to find, use implicit differentiation to find an equation of the tangent line to the curve at the given point. So if I find dy over dx, I will plug in x equals 1 and y equals 1 and find the slope. And then I have a point and a slope. So then we differentiate the left-hand side, we differentiate the right-hand side. Y is a function of x. So 2x plus, this is a product. Function 1, function 2, plus the first function,
Y.
exactly, plus x times,
y prime.
yes,
Y
yes,
prime.
yes, but we prefer writing it as dy over dx, plus 2y dy over dx equals 0. These two,
Why does it say ellipse?
because this is an ellipse. It just
Oh,
tells you what
okay.
it represents.
Okay.
It tells you what it
That-
represents.
so it's also, like I said, hyperbole
Yeah. Yes, it just tells you in parentheses what it is.
And then you want to only keep the dy dx?
Yeah, so I have x plus 2y dy over dx. I factored out. And these
take
two,
the
yes.
Minus 2x, minus 2x plus y. And then divide.
Yes, dy over dx equals negative 2x plus y over x plus 2y. And now I will evaluate it when x is 1, when y is 1. Once I get this number, then I will use y minus y1 equals the slope times x minus x1, in which this is the number I get.
Slope is 1.
And yes, I have 1 and 1. So the top is 3 and the bottom is 3, so you're right, it's negative 1. Very good. Anything else? Is there anything else that you would like to go back to?
Related rates.
Yes, yes. 1 second, Justin, you wanted to look at the
If he has a
logar-
problem ready, like that's perfect.
you also wanted the logarithmic differentiation,
Yeah,
correct?
yeah. But I mean, if he has a problem ready.
And then we look at related rates, or I can we can pick related rates first.
Actually, I have
Let's do 32 on page 249.
And yours, Justin, what was it?
if you want to go over that, I'll.
No, it doesn't. Oh, I thought you already found it, so I can
Oh,
write
no,
it.
no.
That's fine. That's fine.
We also do a implicit differentiation with chain rule. Like where we have.
Yeah, this was implicit differentiated with the chain rule
Oh yeah, okay.
in a way. I mean, it is the chain rule because it's 2y times y prime. But if you have something else in mind, can you choose? Is there something that you want to choose? 240, 249, 241, 7. Yes.
Maybe I'm just missing something simple, but how does that factor to negative 1, 2x plus y over x plus 2y?
So there's a negative.
So 1 and 1. So this is 3 and this
plug
is
x and
3.
y into that.
Yes.
Oh, I see.
So I have to because I need a number.
Okay.
The slope has to be a number, and I'm given the point. So I have when x is 1, y is 1. It happens that 2 plus 1 and 2 plus 1. So 3 over 3 is negative. I'd rather go back and check.
No, you're right. I was just okay.
I'd rather go back and check. It can happen. So do I need to finish this, or can you? Is this okay? Justin?
Oh, yeah.
Okay. So where is 32?
That's not better. Than I thought it was.
Okay. And now I see that 32 has the calculator sign next to it. I don't know what it means. I mean, what it is for. I'm not saying, I don't know. I just see the calculator sign. So let's see. Wasn't is filling a hemispheric basin of diameter. So diameter equals 60 centimeters with water at a rate of 2 liters per minute. Okay, so the diameter is 60 centimeters, and we are filling it with water. So it's something like this. I haven't read everything, so I may come back and change, but for now, this is what we're trying to fill up with water. And we are given that the diameter is this, 60 centimeters. That's what I know so far. And I am told that the rate, with water at a rate of 2 liters per minute. I have to decide what this is before I continue. Is your dog okay?
No.
I hope it. You can solve the problem.
Thank you. Thank you for having a mini stapler.
I can just tell you that my dogs died probably 30 years ago, maybe 25, and I still have their hair in my wallet.
And I told my husband, I was like, if anything
So I
happens,
know.
yeah, and
So.
we're not getting another one.
I stopped once they died. I said that's it for me. I'm done. So good luck.
Thank you.
What does 2 liters per minute represent?
D water ET.
Well, what is measured in liters? What do we measure in liters?
Volume.
Thank you. Right?
Yeah.
So if it's centimeters cubed or feet cubed, cubic feet or meters cubed, whatever, it must be volume or liters. Okay, let's read on. Find the rate at which the water is rising when it is half full. So remember, what follows after when cannot be taken into account till the very last step. So one more time. I didn't finish reading, but find the rate at which the water is rising. So I'm going to say that I'm going to denote this by this height. Let's denote it by h. So we're asked to find what? How fast is the water rising in the basin when it is half full? But when, forget about that. But what am I asked to find when h is half? But very good. And since this is the diameter, which is 30, this is the radius, which is 60. This is the 30. So then when this is half, it means exactly 15. But of course, this means nothing right now because I don't have the function to plug in yet. Okay, perfect. Use the following facts. 1 liter equals 1,000 cubic centimeters. Like we say about engines, right? We say it's a 2-liter engine, which means 2,000 centimeters cubed, or cubic centimeters. The volume of the portion of a sphere with radius r from the bottom to a height h is this, as we will show in chapter 6. So we're given v equals pi rh squared minus 1/3 h cubed. Well, that's nice. That's very helpful. So now dv.
Question.
Yes.
On the test, I mean, some of these, like, I had to, like, look up, and some of the related rates, you have to look up the
Formulas and everything.
formula that you need. Is it gonna be overly clear, like, or are you gonna give us?
Yes, it will be very clear. I'm not going to go to this extent in which you have something that you don't know. I'm not testing anything else but basic understanding of the topics. So you're not going to have anything that, or if I put something like this, you'll have the formula. Honestly, I did not know this myself. I will have to, work on it. But since they're giving it to us, that's fine. So first of all, I have to change this because everything has to be in the same measurement unit. So I will have to say that dV over dt is 2,000 cubic centimeters per minute. I will have to make sure that everything is clear, and I will have to read the problem one more time. Okay, so we are filling a hemispheric basin, very good, of diameter 60 centimeters, which means radius 30, with water at a rate of 2,000 cubic centimeters per minute. Find the rate at which the water is rising when it is half full, which means how fast is the height of the water rising. And the problem we are having here is that if the base were not part of a circle, if you want, then we would have not had to go to the extent and get this formula. But no one knows, how high. If it's for example, a right solid, then we can determine using similar triangles and other procedures. But for this one, no, we can't. So that's why this comes from chapter 6. Okay. So 2,000, okay. Use the following facts, fine. The volume of the portion of a sphere with radius r from the bottom to a height h is given to us. So, what do we do? Exactly. So we know that v is a function of time. We know that h is a function of time. That's all we have to do. So everything is given to us. We don't have to create the function. We don't have to find the relationship between volume and height. It's already given to us. So the left-hand side dv over dt, and the right-hand side is pi.
2r.
Yes. R is a constant for us because it's given to us, 30. So I'm just going to replace it. I'm going to replace this by 30. There is no question there. The radius of the basin doesn't change. That's a fixed number. That I have to use. This I have to use. This I cannot just yet. But that is fixed because that's the diameter. Diameter is 60, so the radius is 30. So 2 times 30 multiplied by h times minus 1/3 times 3 times h squared times dh over dt. Everything is given to us. We have h, which is 15. We have dh over dt, which is 2,000. We have this, again, which is 15 squared this time. And we have this, which is 2,000.
dv dt is 2,000.
Oh, I'm so sorry. Yes. Oh, sorry. This is 2,000. We are determining that.
Yeah.
Thank you. Thank you. A senior moment. You will see when you get to my age. This is 2,000, and we are solving. Okay, these two go away. The 15 with the 30 will go away. It's 2. So 2,000 equals pi. I could have solved and then plug in. It's up to you. So 4 times the variable, which I will pull out, and this is minus 15 squared is 225, and the h over dt. So I had h, which was 15. See what I did? Nobody said anything.
I was just
Or at
wondering
least,
that.
or at least,
you
or
did two
because I
times.
put them all over the place. Yeah, I'm still,
It should be 2, right?
yes.
Okay.
I should not be thinking about my dogs right now. Okay. So this is 30 times 30, which is 900. So 30, 2 times 15 is 30. 30 times 30 is 900. And then 15 squared, that's correct. Here I have to simplify. I think the rest is fine. So the h over dt. I would have gotten a negative answer, and I would have pulled my hair. So 2000 divided by pi times 900 minus 225, whatever that is. So I will, okay, so we have 2000 divided by pi and divided by 900 minus 225. So I got 0.9431. Measurement units. But yes, without the formula, without the relationship between the volume and the height, we would have not been able to solve this. Very good. Justin? Any questions on this? So that's why I highly recommend solve for the age over dt and then plug in. Don't do what I just did.
Could you explain real quick again how you got the height?
Oh.
Yeah.
So this is 60. This is 30. This must be 30.
The assumption is that it's a perfect sphere. It's half.
Yes, it says it's half a sphere.
Got it.
Yes. So then if this is 30, then when it's half full, which means the height is 15.
Okay.
Better?
Essentially half the radius.
Yes.
Okay.
Yeah. Yes, because we're given the diameter.
Oh, right.
Is that okay?
Yep. Perfect.
Very good. Other questions here? Okay, next.
39 and 223, possibly either 49 as well.
Perfect. So let's look at 39 on 223. 226, 222, 223. 39. I see. So y equals x squared plus 2 squared times x to the fourth plus 4 to the fourth. They say use logarithmic differentiation to find the derivative. You don't have to, but since we're asked to use logarithmic differentiation, let's do it. Okay, so natural log y equals, when I apply log to a product, it becomes a sum. So log applied to a product will be 2, and the power goes in front. Natural log x squared plus 2 plus 4, natural log x to the fourth plus 4. Is this clear?
Yes.
So there are two properties that I used in one row. One is log applied to a product, which is the sum of logs, and then the power comes in front as a factor.
Yeah.
Is this okay, everyone?
Yes.
Okay. So now I differentiate the left-hand side and I differentiate the right-hand side. The left-hand side is 1 over y times dy over dx. Agreed so far? Okay. Then on the right-hand side, I have 2. I have 1 over x squared plus 2 times 2x.
Did you write it as 2 over x squared plus 1?
Yes, of course. Of course. Plus 4, 1 over x to the fourth plus 4 times 4x cubed. I will in a minute. I just wanted everyone to see where it's coming from where. But yes, of course, I accept that. You don't have to do it in 2 steps. I'm fine if you do it directly in 1 step. So then I have dy over dx. I will have to multiply both sides by y, which is all this. So x squared plus 2 squared x to the fourth plus 4 to the fourth. And let's see what we have. 2 times 2x is 4x over x squared plus 2. And plus 4 times 4, 16x to the third over x to the fourth plus 4.
Where did the 4x to the third all the way on the right?
The inside function prime. So this is a function u of x. When I differentiate natural log of a function, it's 1 over the function times the function prime. So natural log of u of x prime is 1 over u of x times u prime of x. And that's exactly what we did here. So the 2 is outside, 1 over x squared plus 2 times the inner function prime, which is 2x. according to this. And the same thing here, I keep 4 outside, 1 over this, times the inner function prime, which is 4x cubed.
And you're okay with this leaving like that?
Theoretically, no. Theoretically, no. It has to be simplified. Have to find the least common denominator, and you'll see something simplifies here, right? So one factor will go away, the other factor will go away, and something will happen there. So dy over dx equals x squared plus 2 squared, x to the 4th plus 4 to the 4th. The least common denominator is x squared plus 2, and x to the 4th plus 4. And as you see, 1 will go away from here. I'm jumping ahead again, and I keep an eye on what I'm writing. Okay, so now this one needs to be multiplied by x to the 4th plus 4, and this one needs to be multiplied by x squared plus 2. So 4x to the 5th plus 16x plus 16x to the 5th plus, surprise, I ran out of room, 32x to the 3rd.
So we can leave it like that.
So then x squared plus 2, x to the 4th plus 4 to the 3rd, and then I have 16 plus 4, 20x to the 5th, plus 32x to the 3rd, plus 16x. And I will factor out a 4x from here. So this is x, 4x in front. X squared plus 2, x to the 4th plus 4 to the 3rd, and this is 5x to the 4th plus 8x squared plus 4. This is the completely simplified form of that derivative. Now let's go back and see if you have any questions. Is this clear?
I get it.
Yes? Yes?
Eventually.
Say it again, John?
Eventually.
How did,
Yes? So, okay, so is this step clear?
that's what I was gonna ask.
Okay, so 2 times 2x is 4x. Is that clear? Over this.
Okay.
Plus 16x cubed over this.
Okay.
And I have to multiply both sides by y. That's why this is here.
Oh,
Because I have to find dy over dx.
okay.
So I have to multiply both sides by y. That's why I have this here. Is that okay?
Yeah.
So now, how do I add these two? Well, by finding the least common denominator, which is the product of those two. So then this one, the numerator, gets this, and this numerator gets this. So now 4x times x to the 4th is 4x to the 5th. 4x times 4 is 16x. 16x cubed times this is 16x to the 5th. And 16x cubed times 2 is 32x to the 3rd. But now, since I have this expression here, I will simplify one of them. And I will simplify one of them. So that's why I only have x squared plus 2 and x to the 4th to the plus 4 to the 3rd. And then I combine these, I get this, and 4x comes out. Do you see something that is not clear, or? Is there a question? Just, is this okay?
This,
Okay.
So
Yes?
if instead of just x's, it's like sines and cosines and natural laws left all over the place. I mean, is it then alright to leave it as?
Yes.
Okay.
Yes, of course, because you cannot further simplify it. But if we solve this one more time using the product rule, you'll see what happens. So we have to get this. Same thing. So x to the 4th plus 4 to the 4th. So y prime, first function prime, 2 x squared plus 2 times 2x. So far so good. Times x to the fourth plus 4 to the fourth. Is this okay? First function prime, 2 times x squared plus 2 to 2 minus 1 times the inner function prime times the second function. Plus, I copy the first, and now I differentiate the second, 4. X to the fourth plus 4 to the third times 4x cubed. So far so good? Okay, so then I will factor out, this is much easier in this case, I think, than applying logarithmic differentiation. Yes, logarithmic differentiation. So see, I have a 4x, and I have a 4x from here. So let me write it one more time before we, x squared plus 2, x to the fourth plus 4 to the fourth plus 16x cubed, x squared plus 2 squared times this, x to the fourth plus 4 to the third. So now when I factor out, I have to factor out 4x. I have to factor out 1 of the x squared plus 2, because the power is 1, the power is 2. And I have to factor out x to the fourth plus 4 to the third power. So now what is left? This is out, this is out. 3 of those 4 are out, so x to the fourth plus 4 is left. From 16x cubed, we got out of 4x, so there is plus 4x squared left. This is completely out, so there is 1 left over, which is x squared plus 2. When I combine like terms here, I have x to the fourth plus 4 plus 4x to the fourth plus 8x squared. This is the 5x to the fourth. This is the 8x squared. And this is the 4. We have to get the same answer. But this is much easier than logarithmic differentiation in this case, if you want to go ahead till the end.
Yeah.
So this is indeed 4x, x squared plus 2, x to the fourth plus 4 to the third, and then 5x to the fourth plus 8x squared plus 4, which is the same thing we got here, but much harder. I wouldn't say much harder. I had to find the least common denominator and simplify and so on and so forth. So in this case, I would not request logarithmic differentiation on a problem like this. But you have no choice on 47, on 43, on 45. There is no other way. So I may say, differentiate. And if you don't use the logarithmic differentiation, there is no way we can get the correct answer. Thank you for picking that. That was a good point.
And 49 was the other.
Oh, yes, of course, I forgot. 49. Yes, of course. We did this 49 in class together, but let's do it again. So we have y equals tangent x raised to 1 over x. In this case, there is no discussion. I have to use log, and I have to use implicit differentiation. So here there is no other way. So I have natural log y equals 1 over x, natural log tangent x. So I differentiate the left side and the right-hand side. So this is 1 over y, dy over dx. And the right-hand side will be,
1 over x squared.
careful,
Over x, tan x,
when I differentiate 1 over x, what do I get?
that's just 1.
Negative 1 over x squared. Thank you. So please remember, we have to commit this to memory. It's very important. Otherwise, you will have to reinvent the wheel all the time. How will you differentiate this? First, you have to change it into x to negative 1. And then you have negative 1 times x to negative 2. And then you write this. And there is no need for that if you would like to remember that 1 over x prime is negative 1 over x squared. So times natural log of tangent x and plus 1 over x, 1 over tangent x times secant squared. And yes, in this case, there is nothing you can do, but you have to multiply both sides by y. Is this okay?
And then just multiply by y. And then,
Yes, yes.
Okay.
So dy over dx will be, instead of y, I have to put this.
yeah, tan x.
Yes. Tangent x raised to 1 over x. And then in brackets, -1, or let me write natural log tangent x divided by x squared plus secant squared over x times tangent x. There's no way we can simplify this in any way, shape, or form. Next question, is there anything else that you would like to go back to from this chapter?
So then, just in case.
Anything else?
One thing actually, I see the packet I gave you, so I've got marked a couple that giving me trouble. I'm sorry.
No problem. Anything else?
On 197.
It said 197.
Page 197.
197.
Trig function.
That's okay. 197. Yes.
I guess 33.
Yes. Perfect. For what values of x does the graph of f have a horizontal tangent? So we are given f of x, which is x plus twice sine x. What does horizontal tangent mean?
When it's 0.
Right, when f prime of x is 0. So then we have 1 plus 2 cosine x equals 0. It's a trig equation, so cosine x equals -1/2. So we look at the unit circle. In which quadrants is cosine negative? Yes, because cosine is measured on the x-axis in 2 and 3. Very good. So now I'm asking myself, cosine of which angle is 1/2? And it's not the smallest one, because sine of that angle is 1/2. So it cannot be the small angle. It has to. No. We are talking about 30 degrees, 45 degrees, and 60 degrees. It's not 30, obviously it's not 45. So it must be, yes, pi over 3. So I have to create a reference angle of pi over 3. So 30 degrees, 30 degrees, 30 degrees. So this is the first angle. And this is the second angle. With the same reference angle, which is this one and this one. Same reference angle of pi over 3. So this is pi, and I'm coming back pi over 3. So what will this be? Pi minus pi over 3, which is 2 pi over 3. And now this one is pi plus pi over 3, which will be 4 pi over 3. But there are infinitely many solutions, however, to this. So x equals 2 pi over 3 plus 2 pi k, where k is an integer, like 0, 1, plus or minus 1, plus or minus 2, and so on and so forth. And the other one, 4 pi over 3 plus 2 pi k.
So it would be, since 2 pi k just means forever, right?
2 pi k means
Forever.
if k is 0, we'll only get this. If k is 1, then we get this plus this one with plus 1 complete rotation. If k is -1, then we get this minus a complete rotation. If k is 2, we get this plus 2 complete rotations. Yes, please.
I write plus 2 pi k, but if you wrote plus or minus 2 pi k, k is equal to 1, 2, 3. that also written?
That's fine. However, I've never seen it written like that.
Okay, so don't write.
I would say no.
So for that, we would have to put plus 2K though, like.
2 pi k. So it's one complete rotation at as many times as you want.
But if we just put 2 pi.
So it says for what values of x. So we're not restricted to one.
Rotation.
Yes. Yes. Very good. Next question. Is there anything else you would like to go back to? Anything else? Yes? Good.
Could we do,
Yeah, go ahead.
number 33 on page 255.
33 on 255. 250. 255. Number 33. The edge of a cube, so we have a cube. Okay. Was found to be 30 centimeters with a possible error in the measurement of 0.1. I read the first sentence and I have to think what is 30 and what is 0.1.
So it's 0.1 the
Different.
the difference of dx.
Perfect.
30 is x.
Of course. If 0.1 is the error in x, then 30 must be x. Perfect. Use differentials to estimate the maximum possible error, relative error, and percentage error for computing two things, volume and surface. So we are told this, that we measure the edge of a cube, but we know that there is an error of 0.1 in the measurement. We want to know how much error in the volume will trigger that 0.1 error in measuring x. Because if I have an error in measuring x, obviously there is an error in the volume. It will trigger an error in the volume as well as in the surface area. So we want to know how much will that result in. So I'm asked to find the error in the volume. What am I asked to find?
Volume.
dV, exactly. I'm asked to find dV, which is this is a differential, so I need a function prime times something. What would I have?
Would be a function prime.
Yes, it has to be v prime dx. There is nothing else. So if I'm asked to find y prime, it must be dy. I have to have y prime times dx. If I'm asked to find ds, it must be s prime times dx, right? It's the differential of that function. So remember what we write. We write dy equals f prime of x dx. These two mean the same. F and y mean the same. So these two have to be the same. These two have to be the same, right? Perfect. So where's my starting point for this? Obviously from, exactly, that's the function. If I don't have the function, I don't have anything. So I have to write the function first. Okay, so let's write the function. Very good. So now we're ready to find dV. Perfect. 3x squared. Indeed. If you forget the x, you're not determining the differential. You are determining the derivative. Very good. And I have everything. What I have to do is just plug it in. 3 multiplied by 30 squared times 0.1. So this is 900 with 0.1 will be 90. So this is 270. What? Very good.
So those are for the volume, right?
Yes.
So the volume is always cubed, correct?
Yes. Now we're asked to find the relative error and the percentage error. So dV will be 270 divided by the volume, which is 30 cubed. And that will be the relative error, and the relative error has no measurement unit. How much is it? 270 divided by 30 cubed. I got 0.01. And now the relative error in percent. What is it?
1%.
Very good. So this is the relative error, and this is the percent error. Now we want to do the same thing with the surface. So the surface, I need the function first. Yes, please, John. Go ahead.
So 270 divided by 900. You got 0.01.
It's cubed.
Ah,
That's okay. That's okay. That's okay. Okay, S, surface area.
6x.
Awesome. So now dV, oh, I'm sorry, ds equals
12x dx.
very good. So never forget this, because this is what chapter 5 needs. The differential, please. Okay, so now ds is 12 times 30 times 0.1. So this is 36 measurement unit. Now we want the S over S, which is 36 divided by 6 times 30 squared. What is that?
.007.
0.007? Is it? So simplify, and you get just 6 divided by 900. Yes, perfect. 667 I will write. Good. So now this in percent, no measurement unit. This in percent is 0.667%. Very good. Nice pick. Is there anything else that you would like to go back to?
198,
Yes?
number 46,
46,
and not
198. 198, 98, 46. Okay. So I'm not collecting any more checklists, right? Everyone already turned it in.
Nice.
Thank you. Thank you. So we have limit. As x approaches 0. Thank you very much. Thank you. X approaches 0 from sine x squared divided by x. Very good pick. So as long as I determine and these are all the same, the answer will always be, and I know now I can use L'Hopital's rule, I don't even need the graph anymore. The answer will always be 1. Perfect. So here's what I have at the top, and we can apply L'Hopital's rule now because we have all the tools. So this is what I have here, but I don't have it here. So I have to multiply the top and the bottom by x. Because x squared, when x approaches 0, x squared approaches 0, right? I have the box here and the box here, and where does this go? But this is 1, but x approaches 0, and I still have an x. It's the limit of x when x approaches 0, so it must be 0. Now let's apply L'Hopital's rule. As long as it's 0 over 0, or otherwise we cannot apply L'Hopital's rule. Please remember that. And we can only differentiate top and differentiate the bottom only on a rational function if it's inside the limit. We never differentiate like that, ever, right? Is that clear what I'm saying? So a ratio, we never differentiate top and differentiate bottom.
Right.
We can do that only inside a limit, applying L'Hopital's rule, and only when I have 0 over 0 or infinity over infinity. So never ever apply that procedure otherwise. Okay. Say again. Sorry about that. Okay, so then limit as x approaches 0 from sine x squared over x. When I put 0 in here, how much is sine 0?
0.
Perfect. When I put 0 in here, what is it? 0. Good. So it's 0 over 0, and it's a ratio, right? Of course. So this is limit as x approaches 0. Let's differentiate the top. Yes? No.
So cosine x squared,
Cosine x squared times.
2x.
Very good. Let's differentiate the bottom.
1.
Good. When I plug in 0 here, what do I get? Exactly. Cosine 0 is 1. So this is 1. So 1 times 2 is 2. And when x approaches 0, very good pick. Thank you. Good. Is there anything else that you wanted to go back? Say it again.
How would it be 0? Is 1 times 2?
1 times 2 times x times
Oh,
x.
yeah.
When x approaches 0, 1 times 2 times x is 0.
Yep.
Good. Anything else?
So now that all of the checklists are handed in, could we do a problem that was on the checklist?
Yes, of course.
We have that orthogonal one on the test.
Find two equations. The orthogonal trajectories of each other.
Yeah.
Let's say no.
That was a bonus on the checklist.
Okay.
I'm sure it's on that.
I'll put one as an extra credit to choose from.
Okay. So there's going to be multiple options. of
No more negotiation. This is it. The last one for today. We negotiate again for test 3.
I saw that problem, and I thought that was actually part of the checklist. I was like, oh, I just failed. I was like, oh, God.
Yes. Read.
Number 40, page 223.
Number 40 on page 223. Let's take a look. 223. 224. 223. Number 40. Oops, it looks awful.
Yeah, it was.
Oh, this one? Oh, yeah.
So use logarithmic differentiation. It's not. It really isn't. It really isn't. Use logarithmic differentiation to find dy over dx. Okay. So natural log y will be natural log e to negative x plus natural log cosine squared minus natural log x squared plus x plus 1. Agreed so far?
Yeah.
2 natural log cosine x.
Oh, yeah, I totally did that.
Yes, in a minute. Yeah.
Oh.
I just didn't do the whole thing yet.
Oh, okay.
So then natural log y is, when I bring negative x in front, natural log e is 1.
Yeah.
So this is plus 2 natural log cosine x minus natural log x squared plus x plus 1. So then 1 over y dy over dx
It
is,
should be negative x natural log e, right?
yes, which is 1.
Oh, yeah.
Natural log e is 1. It's a constant, 1, right?
Even if it's. Oh, wait, yeah, never mind. All right, we're good.
So it's plus
2
2
over
over
sin
cosine x times negative sine x, very good, minus 1 over x squared plus x plus 1 times 2x plus 1. And yes, you're right, you can't do anything to it. But I would have to solve for dy over dx.
and multiply by y.
Yes. Jalen, are you turning it in? You have it?
I didn't want to disturb
Okay, that's fine, no worries. No, we're good because we're working on one of the problems. Anyway. I don't want the other students to say, ah. Okay, so dy over dx equals e to negative x cosine squared x over x squared plus x plus 1. And now we have negative 1, we have negative 2 sine x over cosine x, and minus 2x plus 1 over x squared plus x plus 1. And I will not do anything else. I would like to factor out negative 1 and have all plus inside, but that's fine.
Can you,
Yes,
oh, butcher that.
yes. Is this okay?
If I remember correctly, I did not do that. Yeah.
That's okay. That's okay. I'm going to post the solutions on tomorrow night.